Greetings, class. So let's continue our discussion of functions by looking at some key fundamentals of how information is passed into a function. And we're going to introduce two concepts in computing. These not as C-specific concepts. This cuts across programming languages, and these are topics related to called pass by value and pass by pointer. Okay. Now, one of these we've already seen before, though we didn't really discuss it using this term. Okay, but let's look at pass by value. This is the one that's already familiar to you, and we're going to use this to contrast pass by pointer, which is different. Okay, so let's look at this circle. Let's get circle area function again. Okay, now notice we're calling that function down here in the main function here. We're down in main. We've got in the main function scope, we have a variable we called radius. Okay, so let's look at that in terms of writing out the main scope, the main function scope. Okay, and we have our variable radius here. And let's just imagine hypothetically, right, somebody types in, they enter here 5.6, okay? Now, when the getCircleArea function is called, right, we have in that function scope, okay, in the getCircleArea scope, we're going to have variable r, okay. And what I want to point out here is we know, right, that gets set to 5.6, okay? And this is a copy, right? So this value here has been copied, okay? It's a copy of the original, okay? This process of copying one variable to another, right, during a function call by taking this input here that's being passed in and setting r equal to that. Effectively, we have a situation here where it's r is going to be equal to radius, okay? That this is what we mean by pass by value, okay? We're passing the value, okay? We're passing the value 5.6 into the function, right? And making a copy of it. All right, so we've seen that before. We've done that before. And didn't necessarily call it pass by value, but that's what it is, right? We're passing a copy in, and that's how we've learned it so far. However, this is not the only way of passing information into a function. Right? And so to talk about pass by pointer, which is the other one, I want to first talk about when this most often comes up, okay? And a little bit of the reason why. So let's talk about arrays. And we're going to see why pass by pointer, we'll discuss what it is and why it is always how arrays are passed into a function, okay? So we'll get to that, okay? But let's first just kind of recognize that arrays can be very, very large, okay? So I think probably the easiest example to think of how big an array can be for kind of our everyday familiarity standpoint is, let's think about if we've got a 2D array. Okay, we have an image, right? Some image on your computer. Now, effectively, if you have an image on your computer, right, what that is, how that's represented is called RGB values, red, green, and blue, RGB. And effectively, we have 3 of these 2D arrays where each array is storing the amount of red, the amount of green, and the amount of blue, okay? And by mixing red, green, and blue, we can form the other colors that we can see in the visual spectrum. So we're storing, right, when we store a picture or when you're looking at your computer screen, okay, the information that's being shown to you is these tiny little pixels, these tiny little cells on your screen that are shown as combinations of red, green, and blue that define what the color that you're seeing. Okay, so that's how your computer monitors work, and how when you're showing how images are stored, I should say how they're represented. There's actually multiple ways of compressing them and storing them differently, but effectively that's how That's kind of the raw data standpoint. Anyway, so you know, you can see the image here, or the fox is you're effectively being able to, it's a low grade image, and you can see what each little cell here is indicating of a single pixel. It's a mixture of red, green, blue. And if it had a high enough resolution where the pixels got small enough, you wouldn't even be able to see them, right? Effectively, that's how that information is represented. Well, why am I talking about this? Okay, and the reason I'm talking about this is if we're storing data this way, right, which is a 2D array, right, getting a sense of what we mean by expensive is that this is a decent amount of information, okay? And arrays can be very, very large. If we looked at, like I looked at the resolution of my laptop screen, right, it's got over 1 million pixels, right, 1 million of those cells, and if each one of these colors, like each one of these color components is 1 byte, right, you're talking about over 3 megabytes to store one image if you're storing the red, green, and blue individually. Okay, that's a decent amount of data. So what I'm getting at is if we're copying this information, every time you call a function, if you have to copy it, that's actually, you're incurring a decent amount of overhead, right? You're wasting, you're copying a lot of information you don't necessarily have to, and that's wasteful. So we're going to have this, this is a little the motivation for why we want to avoid doing it, okay? So copying arrays every time a function's called is, let's say, quote unquote expensive, right? Expensive because it's wasteful. It could be a large amount of data that you're copying around constantly, and that's, you know, that you're taking a lot of the computer's processing time away from doing other useful work, and you're copying things over in memory a lot, okay? And we can see here is a block of code that talks about what the logic looks like for copying an array. You know, effectively you've got your one array, array 1, you have another array, array 2, and we have a loop, right? And in this loop here, right, we're copying one array to another, each one individually, right? So you have to run through this whole size of the array, copying it over to store information from one location to another. And again, if the array is big, it's wasteful. It's wasteful. Okay, so this is the motivation, right? Why I'm bringing this up is because I'm going to introduce a different way in which how information is passed into a function. But I want you to understand not just what it's doing. I want you to understand why we're doing it, right? And a big part of it, right, has to do with we're trying to avoid this. It comes up the most often when we're trying to avoid this wasteful behavior of copying significant amounts of information, aka arrays, unnecessarily. Okay, so this is passed by pointer is the alternative. Okay, and I'm going to do, I think the easiest way to get what this is doing, and by the way, pointers is a big complicated topic. Okay, what they are, we're going to talk about memory addresses, we're going to talk a lot about pointers. There's a whole big dimension to this, right? We're gonna spend a significant amount of time on it. Right now, I want you to think conceptually what's happening. Okay, one thing to note is arrays, and since strings are also arrays, to recognize that arrays and strings are always passed by pointer. They're always passed by pointer. Okay, it's an important thing to recognize because you know, it's the rule to recognize, and again, it has to do with that they can be of a significant size, and it's a efficiency rationale for why it's designed this way. Okay, so let's look at this example here. This is an example where we have a function called getAverage, and it does what you would expect. It calculates the average of an array. Okay, so let's draw what's going on in memory here. Okay, let's draw this out. So we've got our, let's talk about our main function scope first. Okay. Okay. And we've got what we have here is we've got an array defined, an integer array. Okay. And that's storing some some numbers, 5 numbers to be exact, 2, 4, 5, 9, and 1, okay? And we're also storing actually the number 5 here too. I mean, we're placing it in as a parameter. That's a minor point. I'm actually not even going to show that temporarily. And then we have the getAverage function scope. Okay. And notice we have an array here, okay, that we're passing in as an input, Okay. Now, array, as I mentioned before, all right, it's a key thing to remember. Arrays and strings are always passed by pointer. Always passed by pointer. Now, what that means is what this array A is literally points to the location in memory of where the array is stored. Okay. So I want to point out something here, right? And then we have size, which is going to be stored down here. Right, it's 5. Okay. Thinking of the array in particular, notice there is one copy. One copy of it. Okay? Not two. Not two. Okay? So if I change that one copy, I'm effectively like, so if getAverage happened to do something like, happened to have a line in here that said I don't know, index 1 equals 7, right? Before it returns, we would be changing the one and only copy of the array. Okay? That's the difference between pass by value and pass by pointer. Okay? Pass by pointer, we're operating on the same original copy. Okay? So that if I change it in the function, I'm actually changing it outside of the function scope, okay, which can be dangerous. We'll talk about how to address some of those issues momentarily in another video. Okay, where, okay, pass by pointer, we have two different variables, a copy of it. If I happen to change this one to something else, okay, the original is never impacted. Okay, so which is actually a lot safer in that regard. Okay. So we'll follow up on this, right? I'm going to leave the video short and kind of leave it at that for now. We'll do some other examples to kind of hit this home and really let it sink in, okay? But remember, we're not doing this. This is designed this way for a reason. It's not designed this way to make things confusing for you and to kind of have two different ways of doing something just because. It really has to do with the fact that, you know, arrays can be large, and we want, we don't want to incur all this performance penalty of constantly having to copy data over and over and over again, making copies of it. Okay, so that's the rationale. Okay, and as we learn more about pointers, we can see that how we can use them in other circumstances to our advantage, but we'll save that for another day. Okay, so we'll leave it at that. Follow-up videos, we'll do some more examples of this, and we'll really see how arrays and strings are built. In terms of how we're going to use them effectively and follow proper best practices and using them in the context of functions.